Today we're going to talk about factoring polynomials by using the greatest common factor. Recall that the distributive property states that AB plus AC equals A times in parentheses B plus C. The distributive property allows you to factor out the GCF of the terms in a polynomial to write a factored form of the polynomial. A polynomial is in its factored form when it is written as a product of monomials and polynomials that cannot be factored any further. The polynomial 2 times in parentheses 3x minus 4x is not fully factored because the terms in the parentheses have a common factor of x. To factor the polynomial 2x squared minus 4, we're going to find the greatest common factor between the two terms. 2x squared is 2 times x times x. 4 is 2 times 2. The greatest common factor of 2x squared and 4 is 2. You're going to write the terms as products using the greatest common factor as a factor. So 2 times x squared minus 2 times 2. Using the distributive property, you're going to factor out the greatest common factor. So we pull it to the outside of the parentheses. 2 times in parentheses x squared minus 2. You can always check your answer by distributing the 2 back in. So you would get 2 times x squared and 2 times negative 2. 2x squared minus 4. You should have the exact same original polynomial when you check your answer. Aligning common factors can help you find the greatest common factor of 2 or more terms. To factor 8x to the third minus 4x squared minus 16x, we're going to find the greatest common factor of the three terms. 8x to the third is broken down into 2 times 2 times 2 times x times x times x. 4x squared is 2 times 2 times x times x. And 16x is 2 times 2 times 2 times 2 times x. Their common factors are 2, 2, and x, multiplied together equaling 4x. We're going to write the terms as products using the greatest common factor. So 2x squared times 4x minus x times 4x minus 4 times 4x. We use the distributive property to factor out the greatest common factor. 4x, now to the outside of the parentheses, times 2x squared minus x minus 4. To check your answer, you would distribute or multiply the 4x back into the parentheses. Make sure you multiply the 4x to each term. That would give you 8x to the third minus 4x squared minus 16x. That is the original polynomial, so we know we've factored correctly. To factor negative 14x minus 12x squared, we first need to identify that both terms have a coefficient, or the number being multiplied to the variable, as a negative. So we're going to factor out negative 1. Pulling it to the outside of the parentheses, we get negative 1 times, and now it'll be positive 14x plus 12x squared. Now we're going to find the greatest common factor of both terms. 14x is 2 times 7 times x. 12x squared is 2 times 2 times 3 times x. Common factor is 2 and x, so multiplied together would be 2x. We're going to write each term as a product using the greatest common factor. So we still have the -1 on the outside, but we're going to write -1 times 7 times 2x plus 6x times 2x. And using the distributive property, we pull it to the outside. So we get -1 times 2x times 7 plus 6x in parentheses. We multiply the -1 to the 2x since they both have been pulled out, and we get -2x times 7 plus 6x. To check our answer, we would be multiplying the -2x back into the parentheses. -14x minus 12x squared is our original polynomial, so we know we've factored correctly. Make sure that when you factor out the -1 in your first step, that you include it in all the other steps as you're writing out your steps to arrive at your answer. To factor the polynomial 3x to the third plus 2x squared minus 10, we need to find the greatest common factor of all three terms. 3x to the third is 3 times x times x times x. 2x squared is 2 times x times x. And 10 is 2 times 5. There are no common factors other than 1. So 3x squared plus 2x squared minus 10 can't be factored any further. Here's an example for you to try on your own to factor the polynomial, and then check your answer by multiplying your factored term back in and see if you arrive at the original polynomial. After you're done, you can pause the slideshow, and after you're done, then you can come back for the answer. So you're going to find the greatest common factor. 5b is divided into 5 times b, and 9b is 3 times 3 times b times b times b. Common factor is b, so we write the terms as products using the greatest common factor. So 5 times b plus 9b squared times b. Use the distributive property and pull the b to the outside of the parentheses. We get b times 5 plus 9b squared. And then to check our answer, we're going to multiply the b back in and make sure we get our original polynomial, 5b plus 9b to the third. So we know that we factored correctly. This is a second example for you to try on your own, and then you can check back for your answer. 9d squared minus 8 squared. We're going to find the greatest common factor. 9d squared is 3 times 3 times d times d. And 8 squared would be 2 times 2 times 2. That's one of the 8s. And then 2 times 2 times 2. That's the second 8. There are no common factors other than 1. So 9d squared minus 8 squared cannot be factored further. Here's another example for you to try, and then you can check your answer. If you noticed, both coefficients for the terms were -1, so we're going to factor out a -1, and we get -1 times 18y to the third plus 7y squared. Now we're going to find the greatest common factor between the two terms. 18y to the third is 2 times 3 times 3 times y times y times y. 7y squared is 7 times y times y. Lining up our like terms, we have a y and a y. That would be y squared. We write each term being multiplied to our greatest common factor, so negative 1 times 18y times y squared plus 7 times y squared. We use the distributive property to factor out the y squared, and we get negative 1 times y squared times 18y plus 7. Multiplying negative 1 to y squared, we get negative y squared times 18y plus 7 in parentheses. Here's another example for you to try, so you can pause the video and then check back for your answer. So we're going to find the greatest common factor between all three terms. 8x to the fourth would be 2 times 2 times 2 times x times x times x times x. 4x to the third would be 2 times 2 times x times x times x. And 2x squared would be 2 times x times x. The like terms are 2x and x, which multiplied together is 2x squared. We're going to rewrite so that all of the terms are being multiplied to the greatest common factor. 4x squared times 2x squared plus 2x times 2x squared minus 1 times 2x squared. Using the distributive property, we're going to factor to the outside of the parentheses 2x squared times, in parentheses, 4x squared plus 2x minus 1. We multiply back to check our answer. To distribute back in, 2x squared times 4x squared, 2x squared times 2x, and 2x squared times negative 1 should give us the original polynomial, and it does. To write expressions for the length and width of a rectangle with area expressed as a polynomial, you need to write the polynomial as a product. You can write a polynomial as a product by factoring it. So the area of a court for the game squash is 9x squared plus 6x square meters. Factor this polynomial to find possible expressions for the dimensions of the squash court. So the area, A, equals 9x squared plus 6x. The greatest common factor of 9x squared and 6x is 3x. So we're going to write each term as a product using the greatest common factor as a factor. So 3x times 3x plus 2 times 3x. We use the distributive property to pull that to the outside of the parentheses, and that gives us 3x times, in parentheses, 3x plus 2. Possible expressions for the dimension of the squash court are 3x meters and 3x plus 2 meters. Here's for you to try. So the question is, the area of the solar panel on another calculator is 2x squared plus 4x centimeters squared. Factor this polynomial to find possible expressions for the dimensions of the solar panel. So the area is 2x squared plus 4x. Greatest common factor of 2x squared and 4x is 2x. We're going to write each term as a product using the greatest common factor as a factor. So x times 2x plus 2 times 2x. Using the distributive property, we're going to factor out the greatest common factor. So we get 2x times x plus 2. Possible expressions for the dimension of the solar panel are 2x centimeters and x plus 2 centimeters. Sometimes the greatest common factor of terms is a binomial. This greatest common factor is called a common binomial factor. You factor out a common binomial factor the same way you factor out a monomial factor. So for example, if we had, for A, 5 times x plus 2 plus 3x times x plus 2, they both have the common binomial factor of x plus 2. So we can factor out x plus 2 to the outside of the parentheses, leaving us with 5 plus 3x inside the parentheses. For b, we add negative 2b times b squared plus 1 plus b squared plus 1. Both terms have a common binomial factor of b squared plus 1. Please remember that b squared plus 1 does actually have a 1 being multiplied on the outside, but we don't need to write it. For this example, it is helpful to write it because when you factor out, you don't want to forget that there will be a 1 left over. So we factor out b squared plus 1, and we get b squared plus 1 times, in parentheses, negative 2b plus 1. To factor the expression 4z times z squared minus 7 plus 9 times 2z to the third plus 1, there aren't any common factors. So 4z times z squared minus 7 plus 9 times 2z to the third plus 1 cannot be factored. Here are 2 examples for you to try, so you can pause the video and then press play to find the answers. For A, the terms have common binomial factor of s plus 6. We're going to factor out the s plus 6, leaving us with 4s minus 5 times s plus 6. For B, the terms have a common binomial factor of 2x plus 3. Please remember that 2x plus 3 in parentheses is like saying 1 times 2x plus 3. So we factor out 2x plus 3, giving us 2x plus 3 times 7x plus 1. Here are 2 more examples for you to try. For C, there are no common factors, so 3x times y plus 4 minus 2y times x plus 4 cannot be factored. For D, the terms have a common binomial factor of 5x minus 2. Factored out, and we have 5x minus 2 times 5x minus 2, or you can write that as 5x minus 2 squared. You may be able to factor a polynomial by grouping. When a polynomial has 4 terms, you can make 2 groups and factor out the greatest common factor from each group. For example, if you add 6h to the 4th minus 4h to the 3rd plus 12h minus 8, you could group terms that have common number or variables as a factor. So 6h to the 4th minus 4h to the 3rd plus 12h minus 8. We're going to factor the greatest common factor out of each group. For 6h to the 4th minus 4h to the 3rd, the greatest common factor was 2h to the 3rd, leaving us with 3h minus 2 in parentheses. For 12h minus 8, the greatest common factor was 4. So that left us with 3h minus 2 in parentheses. 3h minus 2 is another common factor. So we're going to factor out 3h minus 2, and we have 3h minus 2 in parentheses times 2h to the third plus 4 in parentheses. You can always check your solution by multiplying the two binomials back together using FOIL. So we get 3h times 2h to the third plus 3h times 4 minus 2 times 2h to the third minus 2 times 4. That gives us 6h to the third plus 12h minus 4h to the third minus 8. The product is the original polynomial, so we know we've factored correctly. If we were factoring 5y to the fourth minus 15y to the third plus y squared minus 3y, we can group our terms, 5y to the fourth minus 15y to the third and y squared minus 3y. Factor the greatest common factor out of each group. For the first group, it would be 5y to the third, and for the second group, it would be y. Now you can see that they have the common factor of y minus 3, so we can factor out y minus 3, which would give us y minus 3 times 5y to the third plus y. To check your answer, you multiply the two binomials back together. So you get y times 5y to the third plus y times y minus 3 times 5y to the third minus 3 times y. That gives you 5y to the fourth plus y squared minus 15y to the third minus 3y. The product is the original polynomial, so we know we've factored correctly. Here's a grouping example for you to try, so you can pause the video and then check back for your answer. So we group terms, 6b to the third and 8b squared, 9b, and 12. We're going to factor out the GCF of each group. So for the first group, 2b squared, and the second group, 3. That leaves us with 3b plus 4 as a common factor for both. So we factor out 3b plus 4, and we get 3b plus 4 times 2b squared plus 3. To check the answer, we can multiply it back together using FOIL. We get 3b times 2b squared plus 3b times 3 plus 4 times 2b squared plus 4 times 3. So 6b to the third plus 9b plus 8b squared plus 12. The product is the original polynomial, so we know we've factored correctly. Here's another example for you to try, and then you can check back for the answer. So we group the terms 4r to the third plus 24r and r squared plus 6. Factor out the greatest common factor, 4r for the first group and a 1 for the second group. R squared plus 6 is the common factor. So we factor out r squared plus 6, and that gives us r squared plus 6 times 4r plus 1. To check the answer, we multiply back together the two binomials, 4r times r squared plus 4r times 6 plus 1 times r squared plus 1 times 6. That gives us 4r to the third plus 24r plus r squared plus 6. 4r to the third plus 24r plus r squared plus 6 is the original polynomial, so we know we factored correctly. A helpful hint: if two quantities are opposites, their sum is 0. So 5 minus x plus x minus 5 would be 5 minus x plus x minus 5. The negative x and the positive x become 0, cancel out, and the 5 minus 5, or the positive 5 and the negative 5, also become 0. So your sum would be 0. Recognizing opposite binomials can help you factor polynomials. The binomials 5 minus x and x minus 5 are opposites. Notice 5 minus x can be written as negative 1 times x minus 5. So you can always factor out a negative and then it becomes the same in the parentheses. So using the distributive property and then simplifying will give you the original binomial. So they're just proving that 5 minus x is negative 1 times x minus 5 if you multiply it back in. So for this example of grouping, we have 2x to the third minus 12x squared plus 18 minus 3x. So we group our terms and factor out the GCF. So for the first group it's 2x squared, and for the second group it's 3. Now we want to write the two binomials we have left in the parentheses. We want them to be the same so they're a common factor to pull out, but right now they're opposites. So we're actually going to pull out a negative 1 as well so that they are the same so we can factor them out. So we're going to pull out a negative 1 from the second grouping term also in addition to the 3, and that gives us the same thing inside the parentheses left over. So now we can factor out the x minus 6 because it's the same. The 3, the positive 3 we had originally pulled out, has now become a negative. So we have 2x squared on the outside still, and then times x minus 6. And now we have negative 3 on the outside times x minus 6. And factoring out the x minus 6, we get x minus 6 times 2x squared minus 3. Here's an example for you to try, and then so you can pause the video and then come back and check your answer. So you group the terms and pull out the greatest common factor. So for the first group it would be 5x squared, and the second group would be 4. If you notice that the binomials we have left in the parentheses are opposites, so we want to pull out a negative 1 as well to the second one, and that gives us a common factor, or the 4, now the positive 4 becomes a negative 4 or a minus 4, and then the common factor is 3 minus 2x now. And so we can pull that out and factor it out, and we get 3 minus 2x times 5x squared minus 4. Here's another problem for you to try, and then you can check your answer. So we group the terms and pull out the greatest common factor. So for the first group it's 8, and the second group is x. If you notice that they are almost written the same, but the second parentheses, they're out of order. So we just want to rearrange it, and then we pull out the y minus 1 as the common factor. And we get y minus 1 times 8 plus